Okay, hello. This is going to be a comparison of the actual September 16th, 2012 minimum with my prediction. Incidentally, when I made my prediction, I predicted that the minimum would occur on the 9th of September, not the 16th. Now, these two images are side by side, which compares the prediction I made on July the 25th and the actual minimum that we saw on September the 16th. So first of all, I'm going to explain what this little arrow is, and that's to make sure that I haven't enlarged one of the images so that the ice looks bigger on one of them than it does the other. I'm just going to prove that by copying this arrow, and you can see I put the arrow on the tip of Greenland, which goes to the southern tip of Neue Zemmler, and you can see that they're roughly the same. I couldn't make them exactly the same, but because I had to rip the image on the left, which is why it looks blurry, from my YouTube video, because as I said, I've lost all my files from all my YouTube stuff, so that's what I had to do, so that couldn't really be helped. So that's the reason for that. Now, back to the actual image. You can see that the distribution of ice that I predicted isn't all that wrong. I mean, obviously there's more ice on the left image than there is on the right, and I suspect that the ice is just getting so thin these days that despite the relatively conductive weather patterns this year for a slow melt rather than a fast one, we still saw a record extent and area this year in terms of the Arctic sea ice. And the difference between extent and area is that area is the amount, it only contains ice that has a higher than 30% concentration, whereas extent contains ice that has a lower than 30% concentration. I should point out that for the last 5 years, the Arctic sea ice volume, which also takes into account thickness, which can be measured in certain locations and predicted by models, and the sea ice volume, which is produced by biomass, has been the lowest on record for the last 5 years. I think it's 5 years, it might be 4, but it's something like that. So obviously we're getting into quite a dire situation. Now I'm just going to discuss a few features. I suggested that the Northwest Passage would be almost or completely open, and it is. Although I have to say that it only opened right at the end of the melt season. Just before the melt season ended, there was still some ice here, and actually that ice was actually older multi-year ice that had flowed into the Northwest Passage. So the Northwest Passage was actually closed until right at the end. The southern route, however, was open somewhat earlier. The northern route, of course, as I predicted, was completely open. This used to be an incredibly rare occurrence, but now it's commonplace for this to happen every year. One other observation is that the concentration I predicted is actually quite a lot lower in some areas than it actually was observed. Now, this image here, I sort of looked at a variety of satellites and tried to come up with the best guess of what the ice actually looked like. But I should point out that the concentration might actually be quite a lot lower than some of these satellites suggest, and I'm taking knowledge from the Julian Strove expedition, where the sea ice concentration measured is actually a lot lower than many of these satellites suggest. So I'm just going to throw that out there. But even considering that, the distribution of ice was fairly similar. So the higher concentration ice is in roughly the same place that I predicted it would be. I didn't anticipate the August cyclone that ripped up a lot of the ice in this northern area, so that might partly be the reason why there's no ice in this upper area, because obviously it's not northern if it's away from the North Pole, but you know what I mean, in this area here. But I don't think that the August cyclone can be blamed for all this, because the ice is just so thin anyway that the August cyclone definitely did help, but there's a good chance it would have melted anyway. So that's a direct comparison between these two images. I think I did okay. What I'm going to do is make that comparison a little bit easier to see with this image. So this image is one image overlaid on the other, and then the difference is shown. I think actually I've got this little bit here a little bit wrong, and some of this shouldn't be in the dark blue colour. But what I've done is I've taken the ice that appears on one image and doesn't appear on the other, outside of the ice pack, and I put it onto here. So the lighter blue is the low concentration ice outside of the prediction ice pack that appears, and the dark blue is the moderate concentration. So I haven't actually compared the concentrations within the actual ice pack, I've just compared it outside. So you can see obviously it's going to be around the edges that I'm looking at. So there's a lot more ice in this sort of in the Fram Strait than I expected, but you can see that the biggest loss is over in this region here. Again, the part of the factor that caused this ice to go was the August cyclone, but part of the reason why the ice has gone is because it's so thin. Anyway, you can see where the ice difference is, and the red colours are where the ice was in, where there was more ice present in my prediction than there was actually in the actual. So I think that's fairly clear. Okay. So I'm going to actually have a look at an extent, and the reason this is an extent graph from one of the particular satellites. This is actually the DMI. And the reason that I've used extent is because I was looking because my graphics showed a lot of low concentration ice. So I probably included some of the ice that was lower than 30%. So I'm going to look at the extent graph because that's probably a fair comparison. I didn't include this on my previous video, but this dashed line was where I expected the ice to roughly the expected track this year, starting from when I uploaded that YouTube video last. But you can see it went well below any of the previous predictions, and we will set a new record for 2012. I think the primary reason why this was is because there's very little multi-year ice left in the Arctic basin now. So, I mean, all the multi-year ice that seems to be left seems to be near the Canadian archipelago. So there isn't an awful lot left. I think that's probably the reason why we saw so much melting this year. And this is despite weather conditions that were not like 2007. In 2007 we saw weather conditions that were perfect for ice loss. It wasn't the case this year, apart from of course the cyclone that I keep referring to. But apart from that, we shouldn't really have seen this sort of drop, and the reason that we probably did is because my guess is that we're past the point of no return now, and we could easily see by the time we get to 2015 a virtually free Arctic basin in the summer. I still expect there to be some ice in the Canadian archipelago, but by the time it's 2015, I will almost definitely be below the 2 million kilometre squared mark on this ice extent. That will be my prediction. Okay, so to end this video, I'm going to end with a picture. This picture was a webcam in a buoy that was quite near the North Pole. I don't think this is actually on the North Pole because the buoys tend to drift about as the ice pack moves. But this is quite a nice image that was recorded a couple of days ago since I recorded this video, and it shows that a lot of the melt ponds that were near that were on the ice near the North Pole have frozen over, and now there's a covering of snow. So obviously winter's coming in the Arctic. We're starting to get snowfall. The temperatures, when I last looked, temperatures near the North Pole were about -12, -13. In the central Greenland area, they're as low as -35. So we can say that winter's on its way, but I don't think it's going to be enough to prevent a cataclysmic event happening from next year. And I should say that despite these low temperatures, they're not lower than expected. In fact, they're actually higher than we would expect for the time of year. And sea surface temperatures are similarly very high, in especially some parts of the Arctic basin. I'm looking at particular areas north of Canada and areas near the island of Neue Zembla. I'm talking about the Kara, the Barents Sea, that sort of place. Anyway, hope you enjoyed. Thanks for watching.